Hello. Welcome. Today in this video we are going to create an AI inventory app using Python. It will include AI features like AI restock suggestion and smart analytics. So without any wait, let's start the video. We start by defining an item class to represent a single product. This gives us a simple, consistent object the inventory can store and manipulate. The constructor captures the three key pieces of data: name, current quantity, and a minimum alert level, so every item knows both what it is and when it might need restocking. Here we store those values on the instance using tuple-style assignment that makes each item a tiny record the rest of the app can read and update. With item defined, we create an inventory class which acts as a manager. It keeps a list of items and exposes methods to add, view, analyze, and sell them. The inventory's constructor prepares an internal container so the app has a place to keep all item instances during the session. We use a list call data to preserve insertion order and make it easy to iterate, append, and run simple analytics over the items. The add method accepts the item's attributes and creates a new item. This keeps item creation encapsulated in one place. Appending a fresh item to self.data stores the product in the inventory so subsequent operations can find and manipulate it. A friendly confirmation message gives immediate feedback that the add operation succeeded and shows the values recorded. View is responsible for presenting the inventory to the user. It handles the empty case and otherwise iterates items for a readable listing. If there are no items, we early return after printing an explicit message that avoids running the loop below on empty data. When items exist, we enumerate them starting at 1 so each line shows a human-friendly index alongside the item's details. For each item we compute a quick alert string when quantity is at or below the minimum threshold so low stock items stand out. Finally, we print a concise line per item showing its index, name, current units, minute alert level, and the low stock warning if applicable. The I_restock method scans for items needing attention and presents a short suggestion list. Think of it as a tiny helper to spot restock candidates quickly. We build a list comprehension that filters items with quantity at or below their minute threshold so the suggestion only includes relevant SKUs. If the filtered list is non-empty, we proceed to print the suggested items, otherwise we confirm everything looks good. A short header introduces the suggestion section so it stands out in the console output. We list each low stock item on its own line with name and current quantity so the user can act on them immediately. If no items are low, we take the opportunity to reassure the user the stock levels are healthy. A concise positive message communicates that no restock action is currently required. Stats provides quick aggregated metrics, highest, lowest, total, so you can understand the inventory shape at a glance. If there are no items, we return early after printing a clear message. Aggregation requires at least one record to be meaningful. We use max and minute with a lambda on quantity to find the items with the highest and lowest stock quickly and efficiently. A simple sum over quantity gives the total units in the inventory, useful for capacity or supply planning. We display the item with the highest stock to highlight any overstock or best supplied SKU. Conversely, we print the lowest stock item so you can quickly spot potential shortages. Finally, we print the overall unit count to give a high-level sense of inventory size. The sell_item method implements a simple sale flow: find the item by name, verify stock, and decrement the quantity if possible. We locate the item case insensitively using next with a generator. If nothing matches, we get none, which we check below. If the item was found, we enter the success path to check quantities and perform the sale. We ensure the requested sell quantity does not exceed available stock to keep inventory counts accurate and avoid negatives. On a valid sale, we subtract the sold units from the item's quantity, updating the in-memory state immediately. A confirmation message shows what was sold so the user sees the operation's result clearly. If the requested quantity is too large, we handle that gracefully rather than allowing the stock to go negative. A clear warning tells the user they attempted to sell more units than available so they can correct the request. If the item lookup returned none, we show an explicit not found message so the user knows the name didn't match any SKU. This feedback helps the user either register the missing item or correct a typo in the name they provided. Above the CLI surface, we define an app class to wire everything together. It will own an inventory instance and present the interactive menu. The app constructor initializes the runtime controller. This centralizes app-level resources like the inventory. We create an inventory instance and store it on self.inv so menu actions can call the inventory methods directly. The run method implements the interactive loop. It prints options, reads input, and dispatches to inventory actions accordingly. An infinite loop keeps the menu active until the user explicitly chooses to exit, enabling multiple operations per session. A header is printed each iteration to keep the interface organized and to separate repeated menu prints visually. Menu option 1 maps to adding a new item. The text here reminds users what number to press for that action. Option 2 will let users see the current inventory listing produced by inventory.view. Option 3 triggers the small helper that suggests which SKUs need to be restocked. Option 4 shows aggregated stats, highest, lowest, total, so users can quickly assess inventory health. Option 5 initiates the sell flow, which decrements stock for a given SKU after validation. Option 6 cleanly exits the app when the user is finished. We read the user's menu selection as a string and use it to decide which branch to execute next. If the user picked 1, we run the add item path, which collects the required fields and calls the inventory's add method. We prompt for name, quantity, and minimum alert level, converting numeric inputs to integers so the inventory stores proper numeric types. With the collected values, we call self.inv add to create the item and append it to the inventory list. If 2 is chosen, we delegate directly to inventory.view to print the current inventory to the console. If 3 is chosen, we call the restock helper to surface items at or below their minute thresholds. If 0 is selected, we call stats to show highest, lowest, and total unit metrics. Choosing 5 triggers the sell item flow, where we ask which item to reduce and by how many units. We capture the target item name and the quantity to remove, converting the latter to an integer for arithmetic. Then we pass those values into sell_item, which handles existence and stock checks before updating quantities. If the user chooses 6, we politely say goodbye and break out of the loop to end the program. For any other input, we print an invalid choice message so the user knows to enter one of the listed options. Finally, creating an app instance and calling run launches the interactive CLI. This ties together all the pieces so you can manage inventory in a single session.